I'm going to talk more about instruments for climate policy. We made a start last week. There's two bits of theory left to be done, but I'm today mostly going to talk about the practice of these things. I'm going to start with a brief recap of what I talked about last week. So last week I took you through a tour of possible policy instruments. The first one is direct regulation. I argued that it's very hard to get this right. And as one example, you know the computer lab that we're in. Some of you are in Pevensey. This is fine but noisy. S-Town, you may have noticed, is very hot and stuffy. So I talked to the authorities about this, and the regulation is that there must be certain equipment in the room. The regulation is not that the air quality in a room has to be meet a certain standard. The regulation is that the equipment has to meet a certain standard. And clearly, that fails in S-Town, right? Because it's too hot, it's too stuffy. It's simply very difficult to get direct regulation right, because different people use the equipment very differently, and equipment can be very different. And it's only when you have sort of a homogeneous use of homogeneous technology that you can imagine that a civil servant would set the regulation in a way that is both environmentally effective and economically efficient. Then I talked about taxes and subsidies, which are equivalent in the short run because they both increase the costs at the margin of increasing your emissions or create a benefit for reducing your emissions. But I also said that in the long run, they are not at all equivalent because taxes reduce the profitability of an industry, of a polluting activity, whereas subsidies increase the profitability of a polluting activity. And therefore, in the long run, subsidies attract more pollution. You got why they are equivalent at the margin. Okay. If you pay a tax on your emissions, if you increase your emissions, you pay more tax. That is a cost to you. If you get a subsidy for reducing your emissions, when you increase your emissions, you don't pay a tax, but you forego a subsidy. So it's the double negative. The tax is a negative subsidy, but instead of paying more, you forego, right? Now, they work the opposite way on the average cost and therefore on the profitability of your investment. Because with a tax, you're losing money, you're giving more money to the government. Subsidy, you're getting money from the government. So your average costs have gone down with a subsidy, but have gone up with a tax. And therefore your return on capital goes up in case of a subsidy and goes down in case of a tax. And if your return on capital has gone down, you want to invest less in this activity. But if your return on capital has gone up, you want to invest more in this activity. Right? Then I talked about tradable permits, how they work in principle, and they, in a perfect market, work to equate the costs at the margin for the various polluters. And then I concluded with the Coase theorem. I talked about various ways of allocating those permits, and said that by Coase, it doesn't matter for the market. It does matter for the distribution of the costs, but it doesn't matter for the price or the final allocation. So that is where we were. There's two pieces of theory that you need to do. First is Baumol, the other is Weizmann. We can judge different policy instruments by very different, many different criteria, but one of those criteria is cost effectiveness. And that is essentially, do we meet our targets at the lowest possible cost? Now, cost effective is a bit of an awkward word in English nowadays. Cost effective is a term, as far as I know, that has been come up with by economists, but has now also acquired a colloquial meaning. It's often the other way around, that we have a colloquial meaning of a word, and then economists use that word and attach a special meaning to it, and that confuses everybody, right? In this case, it's the other way around. This is an economics term that has gotten into standard parlance. Cost effective means that you meet your target at the lowest possible cost. If we speak economics, in colloquial use of the word, cost effective is a synonym for cheap. This is nonsense. We have a good word for cheap that is much easier to spell and much easier to pronounce, right? It's a bit silly to use a longer word. But a lot of people do, and a lot of people also speak about more cost effective or less cost effective, which just goes to show that they did not understand the meaning of the word in the first place. It is the cheapest possible way of meeting your target. It's an optimum, an extremum. You're either cost effective or you're not. You cannot be more cost effective or less cost effective, just as you can't be more or less optimal, right? And it just doesn't make any logical sense. So, we want to meet our target at the lowest possible cost. What does that imply? Let's assume that, and I notice that I'm again changing rotation. M here is emission reduction, not emissions. And let's assume that we have a quadratic cost function in emission reduction, beta m plus gamma m squared. These are the actions of individual polluters. Cost effectiveness means that we want to minimize the cost of our intervention. So we want to add up all the costs. That's the summation that you see here. And of course, we want to do that subject to the constraint that the sum total of emission reduction here is at least equal to our target m. So in order to solve this problem, we form the Lagrangian. Lagrangian is simple. We take the objective function, the sum of the costs, minus the swap these two. Plus the shadow price times the constraint in a slightly awkward way. Normally you have a minus here, the plus here is on the other side. Doesn't matter. So we form the Lagrangian. And then you take the first partial derivative of the Lagrangian to the thing that we decide on, that is how much emissions to reduce. So we do EL to n, which, but it's a nice quadratic function from beta plus 2 gamma n. And then we have the minus here, right? The first partial derivative of this thing, 0, right? Doesn't depend on n. Of all the other terms, all the other polluters are irrelevant, right? So we just have the first partial derivative of mn to mn, so that is 1. So we end up with a lambda here. We bring this to the other side of the equation. Now what we find is that the cost-effective solution, the way to meet our target at the lowest possible cost, has the condition that the costs at the margin are equal to lambda But the key insight is that marginal costs have a subscript n, but a lambda shadow cost is the same for everybody because we have a shared constraint. It doesn't matter who emits CO2. The only thing that matters for the climate is the total emissions of CO2. Doesn't matter whether you emit it or I emit it or somebody in China. The effect on the climate is the same, right? And that is a crucial insight. Because it's a shared constraint, the first order condition for cost effectiveness says that the costs of emission reduction should be equal for everyone at the margin. Right? Now, what happens if we introduce a tax? Well, the costs, this is one more, by the way. Because the previous one was just a grand, right? The cost function changes as follows. Still, the cost of emission reduction are the same, right? Beta plus gamma, beta m plus gamma m squared. But now, for every ton you reduce your emissions, you pay less tax. So you need to subtract Tm from that, right? This is an unconstrained optimization. So still choose M, there's no constraint, there's just a tax imposed on your company. So what do? You set the third party derivative equal to 0 to C, the M for all companies. N must be equal to 0, that is beta plus gamma, 2 gamma M minus P equals 0. So the cost at the margin of emission reduction equal the tax rate T. And provided that everybody pays the same tax, you automatically end up in a cost-effective situation, right? If we have a subsidy, then for every unit of emissions that you reduce, you get money. To reduce your emissions, you get you pay less tax, right? You reduce your emissions, you get a subsidy, so your costs fall. So this should be a minus. But the structure of the equation is the same, right? If we solve this, or if we optimize this, what we find is that Tmn is equal to S. The only real difference between this is that we have a T and an S, but other than that, there's no difference. Similarly, if you in a system of tradable permits, if you cut your emissions by M, then you have permits to sell. You sell them at price P, and your costs fall. And we optimize this, we again get this condition, right? So provided that we have a uniform tax or a uniform subsidy or a permit market that is perfect in the sense that everybody pays the same tax, pays the same price for their permits, these policy interventions are automatically cost effective. Right, so they meet the target at the lowest possible cost. Of course, it may be that the target that was set is a silly target, and it may not be an efficient solution, but it's guaranteed to be a cost-effective solution. Right? Now, this is what I just said. with command and control, with direct regulation, there's absolutely no way of guaranteeing that the costs are equated at the margins. That automatic guarantee is simply not in there, right? Unless it is the case that the regulator knows everything about everyone in the economy, right? Then you can, and has the freedom to actually differentiate its technological standards. Another important criterion by which to evaluate policy instruments is whether they do actually good for the environment, right? An obvious thing that we would want your environmental policy to do. Come out fine here, because definitely if you set a standard on emissions, then assuming that everybody obeys the regulations, you meet your target, right? Because that is what happens. But at the example that I just gave about the regulation of air quality in buildings, if the target, if the regulation is instead aims at the technology that is in the room rather than the quality of the air that is in the room, then you may not meet these targets. I think 2 weeks ago we also talked about, maybe it was last week, about utilities dumping raw sewage into rivers and seas, right? That is illegal, right? They're not allowed to do it. The problem there is enforcement rather than that the regulations are not done. But if you do away with illegality, then provided that you set your standard on the emissions themselves, you're actually certain what comes out. Now, if you use tradable permits, you are in the same situation, right? Because you put an overall cap on emissions, you know what your total emissions are. So from the perspective of the environment, this is a good thing. You know exactly what you emit, right? And you can just plan your emissions years in advance. But of course, what you do not know is how much this will cost. Because you impose this target, 100 million tons of CO2 will be emitted next year. And then you leave it to the market to sort out what the price of permits would be. Unless you are able to perfectly predict that price, you do not know what the cost will be, right? At least at the margin, and therefore also not in total. So that is a big disadvantage of tradable permits. You know the environmental effect, but you don't know the economic effect. With taxes and subsidies, it's the opposite. You impose a tax, and therefore you know what the costs at the margin will be, because that is your tax, right? That is your subsidy. And therefore you have a pretty good idea of what the total cost would be. But you don't know what the environmental effect would be, right? Unless you happen to know what everybody's price and substitution elasticities are like, which you typically do not know. I mean, we assume that people know this when we write down our economic models, right? But of course, regulators in real life do not know that, right? So taxes and tradable permits in one way are very similar. They equate the cost and the margin for everyone, so they're cost-effective interventions. If you auction your permits, you get a lot of revenue for the Treasury. Just as if you impose a tax, you got a lot of revenue for the Treasury. So in that sense, they're very similar. But in this sense, they're the opposite of each other, right? With one, the economic effects are known, but the environmental effects are not known. And with the other, it's the other way around. The environmental effects are known, but the economic effects are not known. So that begs the question, can we actually quantify this trade-off? Can we actually say which of the two is better in what circumstance? And the answer is yes. And the answer is found in the Weizmann theorem. So I'm going to start with the cost-benefit diagram, where we have quantity on the horizontal axis, we have price on the vertical axis, we have the marginal impact of our emissions going up in green. If there's no emissions, there's no effect, right? The higher the emissions, the worse the situation gets. And here we have the marginal costs of emission reduction again. Whereas if we do our unregulated emissions, we have no costs, but if we push emissions down and down and down and down, it becomes more and more expensive to do so at the margin, right? And then the optimal regulation is to either impose a tax P star or impose a quantitative restriction and have a system of tradable permits with a total emission of Q star. This is the quantity target that we impose, and this is the price that we would resolve, and this is the price that we would impose, and this is the quantity that would resolve. Right? So this is the equivalence of taxes and tradable permits. Now, let's assume that the regulator doesn't know everything. Fair assumption. Let's assume that the regulator gives into the industrial lobby and thinks that the costs of emission reduction are higher than they really are. And that is the red curve that you see. What would happen? Well, this is the optimal point, right? But the regulator doesn't know about the brown curve. The regulator thinks it's the red curve instead. So with tradable permits, it's going to impose not a target of Q star, but of Q prime instead. It's going to let more emissions take place. There's less emission reduction, right? So there's under-regulation if we use tradable permits, and we make this mistake. The regulator uses a tax instead, then the regulator would opt for the price P prime, which is higher than P star. There is over-regulation in this case. So my story that they gave into the industrial lobby only makes sense if the industrial lobby expected that it would be tradable permits rather than taxes, right? If you expect there's going to be taxation and you are an environmental activist, then you should argue that environmental regulation is more expensive than it really is. Because that will lead to over-regulation. So the symmetry between taxes and tradable permits is now broken down, right? One leads to over-regulation, the other leads to under-regulation for the same mistake, right? That a regulation is. Now, which one is worse? The welfare cost of under-regulation with tradable permit is the blue triangle that you see here. Which consists of two parts. One, there is, because the regulation is less stringent, the cost to the polluters falls, right? And it falls by this amount, the area under the curve, right? Between the two forms of regulation, between the two levels of regulation. This is the additional cost, or this is the cost saving to the polluters. But we also have that the environment is not regulated stringently enough, so there is a welfare loss from that perspective, and that is the area under this curve, the area under the green curve between the 2 points of regulation, right? And the difference is the Harberger triangle that you see here, right? Taxation, under regulation, we go for quantity double prime. There's over-regulation, so the polluters pay more than they should have, and that is the area under, again, on the brown curve, so that is this area here. But the environment has a gain, right, because there's more regulation, and the welfare gains on the environmental side are the area under the green curve, which is this area here, and the difference is the pink triangle. Where you are sitting, the blue triangle and the pink triangle are the same size. And that is actually true. If you calculate this exactly, then the two triangles are the same size. So from a macroeconomic perspective, we're again indifferent between taxes and tradable permits. The distributional consequences are different, right? Because if you go for under-regulation, we shift the burden from the polluters to the environment. Whereas if you go for over-regulation, we shift the burden from the environment to the polluter, right? So distributional consequences are different. Like you may have an opinion on that, but from an aggregate perspective, we are indifferent between taxes and tradable permits. So far, the Weizmann theorem did not teach us a whole lot. But I would not be talking about this if there were not actual implications of the Weizmann theorem. Now, I drew these curves, and the question you may ask is what would happen if one of the curves has a greater slope, more steep, or steeper, right, is the English word. Well, if that happens, if the green curve becomes steeper than in the original assessment, then the blue triangle shrinks and the pink triangle grows. The under-regulation with tradable permits becomes less pronounced, but the over-regulation through price instruments becomes more pronounced if the curve becomes steeper. And as a result, the two triangles are no longer equal in size. And if this is the case, if the marginal damage cost curve is steeper than the marginal emission reduction cost curve, then the welfare loss of using a system of tradable permits is much smaller than the welfare loss of using taxation for the same mistake about the costs of emission reduction, right? And lo and behold, if the marginal damage cost curve is less steep, if the green curve flattens, then the blue triangle grows in size and the pink triangle shrinks. This is just a reverse mechanism, right? And in this case, making a mistake with quantity instruments is much more costly than making the same mistake with a price instrument, right? So, but if the two are equally steep, then from an aggregate perspective, you cannot say which of the two. Now this is the Weizmann theorem. If the marginal damage cost curve is less steep than the marginal abatement cost curve, then mistakes with price instruments, that is taxes, are less costly than our mistakes with quantity instruments, like it's tradable permits. And if the marginal damage cost curve is steeper than the marginal abatement cost curve, then mistakes with quantity instruments are less costly than our mistakes with price instruments. And this is the Weizmann theorem as Weizmann originally wrote it up in a completely different context, right? Weizmann was interested in a planned economy versus a market economy. That is why he wrote this. And the interpretation that you see here, taxes versus tradable permits, is much later, and therefore the picture that you see is of Weizmann at an older age. Now, why do I talk about this? Because this was just theory, right? In climate, we actually know the relative steepness of the two curves. And the intuition is as follows, or the mathematics is that environmental pollution or climate is a stock pollutant, right? And because it's a stock pollutant, because climate change depends on the emissions that accumulate over decades and centuries. Doesn't really matter to the climate whether you reduce your emissions by a little bit more or a little bit less, because the climate does not respond to that, right? And because the climate responds so very little to small changes in emissions, the impacts of climate change do not change much either. And that is one of the exercises that we did this week, right? In just a 5% emission reduction. In our model, just cut 0.2 of a degree from the temperature, the global surface air temperature in the very long run. Not a whole lot, right? So the marginal impacts do not change much with small changes in emissions. But we also found that, let's see, if you increase your emission reduction target, then your costs actually go up fairly rapidly, right? So if you are in charge of a medium-sized country for between elections, it's typically in the UK between 5 years, right? That somebody can expect to be in charge. At the moment, it's a little bit less than that. But suppose that you are the Prime Minister of the UK and you have 5 years to push through your agenda and you want to cut emissions. Now, actually, what you do with those emissions, it does not really affect the climate, right? A little bit, but not a lot. And therefore, it also does not affect the impacts of climate change that much. But if you set very stringent targets, and it does affect your economy, right? So making a mistake with how stringent your climate policy is could have real economic consequences, but does not have real environmental consequences, right? And that is the reason why, in this particular case, for a stock pollutant like greenhouse gas emissions, you should go for taxes rather than tradable permits. So that was the theory for the whole block. I did write a Shiny app that's in R that you can actually play around with these things for yourself if you prefer computer animation over me standing in front of a screen. Let's now look at the practice of climate policy. We've said two things, right? We've said that prices should be uniform, taxes should be uniform, and because CO2 is a global pollutant, it has to be equal across the globe. And we have said that taxes are better than tradable permits. So, what did our dear leaders do? They opted for tradable permits. There's few carbon taxes around the world, but there's a great many systems of tradable permits, right? And they got that message wrong. And it's not that there is one system of tradable permits, but there are multiple systems of tradable permits. The first one that you see listed here was active for a while, or joint implementation was active for a while, now mostly defunct. There is a provision in international law to have emissions trade between the rich countries of the world, the members of the OECD, but that has never happened, right? That market exists on paper, but not in reality. This market for joint implementation used to exist, it doesn't anymore. The clean development mechanism, and I'll speak about towards the end of the next hour, maybe the middle, is alive. So I'm going to talk a little bit more about that. Then within the EU, we have the what used to be called the emissions trading scheme, is now called the emissions trading system. And then there's a separate one for aviation. Then there is a permit market in the northeastern parts of the USA. There's one in California that is tied to Quebec. There's one in Ontario, one in Nova Scotia. There's 10 in China. There's one in New Zealand. There's one in South Korea. There's one in Switzerland. There's one in the UK. One in Germany as well, even though it is also part of the EU. And some people say that there's also one in Kazakhstan, but I've never been able to find real evidence of that. So if you added this up, you found that there are 21 markets. And of course, if you have 21 markets, you have 21 prices. And the first order condition of cost effectiveness says there should be one price. Reason, there's 21 prices. And there's some convergence. If you look at prices in Europe, for instance, we have the EU ETS, right, going on here. What you see is that the UK ETS, which is, I did not make these colors, it's just in purple rather than blue, so that you can hardly see the difference. Not very sitting or where I'm standing. You see that they're not equal, but they track fairly well. Also, the price in Switzerland actually is not too far off. The other ETS in Germany has a much lower price, right? So the law of one price breaks down here already. The scale of this graph is up to $110 per ton of CO2, and ton is metric ton. If we move to North America, then the scale changes from 110 to 30. And you see that the northeast of the United States has a very different price than California. California and Quebec used to be separate, but then they merged. Also, the price within Canada is a little bit different, right? But the price within the US shows greater differences. And of course, there's large parts of the US that have a zero price, right? That is not shown on this graph. And these prices are very different than the prices you see in Europe. If you look at Australasia, you see something similar. New Zealand, South Korea, China, right? This is not the same price, obviously. And also the prices, as you can see on the scale, are different from what you see in Europe. And then if you look at what is going on in China, you see that these 10 different markets in China also show a great variety of prices, right? Now, the one thing I hope you won't ask is how can there be a nationwide ETS in China and then 9 city or province markets? I don't know how they do this, but they do. I've asked my friends in China how this works, and their answer is ask someone else, because I don't understand it either. So we don't know. So there's obviously, we're far away from a cost-effective solution, right? We did not unify the price of CO2 emissions. Now you may ask the question, so we have these 21 systems or so, and I haven't shown them all. Why can't we just couple these markets and create a large unified market? And the answer to that question is perhaps a bit different than you would have expected. So can there be an international market? Of course there can be an international market. Actually, long distance trade is much, much older than the nation state, right? It seems to be a natural thing that humans do, that they trade with each other. And as far as we can look back into archaeological records, people have traded over very long distances, long before there was anything that you would call a nation or a state, let alone a nation state. But we're not trading in goods. It's not that a emission permit is like a loaf of bread that we can exchange for something, that I could give up my food and I get something from you in return, and we're both better off, right? It's not a tangible thing that we can swap, right? It's not a barrel of oil that you can just use anywhere across the planet. Now, a emission permit is a permit. It's a government license. And it's only valid within the jurisdiction of that particular government. You cannot take a Chinese emission permit and use it in the United Kingdom, because the UK regulator only accepts UK permits. Actually not true, it's the four countries that do it, so you need an English permit or a Welsh permit or a Northern Irish permit or a Scottish permit, right? So in order for there to be international trade in permits, what you need is an explicit recognition that foreign permits, say EU permits, are valid in the UK. And then preferably that should be a mutual agreement that UK permits would also be valid in the EU, right? So that is needed. This is not a good that you would be naturally happy to trade. And even if trade is forbidden, people would smuggle it across borders. No, it's absolutely pointless to smuggle permits because you can't use them in the country. You can only use them in the country of origin, right? So you may say, well, this is difficult because permits are different. Different countries have different regulations on what is exactly included in the emissions trading system, or they may have different ways of counting emissions. And that is something that a lot of people forget, that don't measure CO2. What we do is we measure energy inputs, and then we look up our chemistry and say, well, if you burn a liter of gasoline, you emit so and so much kilograms of CO2. And it's the energy input that we measure, not the CO2 output, because then that actually requires a sizable chemical apparatus that you don't want to carry around all the time, right? So we measure energy input rather than emissions output. And energy statistics are relatively reliable, but also there's a lot of greenhouse gases coming out of agriculture. And we know that trees soak up CO2 and grow, and we can sort of like see how trees grow, the above ground part of the tree. We can sort of measure how they've grown and therefore how much CO2 they soaked up, because they're essentially carbohydrates, right? So you can figure out how much carbon is stored in a tree, but you can't measure the roots, right? Not easily, not without taking the tree down, right? Defining its purpose. So there's actually a lot of uncertainty about CO2 emissions. And therefore, because we're trading permits, right, different countries write different rules about how exactly to measure CO2 and how exactly to define CO2. So that is different between countries, but also enforcement can be very different between countries. And I'll come back with an example there. So it's actually, you can't say that a Chinese permit is the same as a European permit. What you could do is, well, the same is true on the capital market, right? lending money to Germany is not the same as lending money to the UK, or lending money to the German government is not the same as lending money to the UK government. And we have this whole system of rating agencies that tell you, yeah, perhaps the risk of default is a little bit higher in the UK at the moment than it is in Germany, right? You apply a discount because other countries don't enforce their permits or their emission permits as well as we do, so we discount them. Instead of, they say that it has a nominal value of 1 ton of CO2, we really believe it's only 0.75 tons of CO2 that have been emitted. Right? You can do something like that, absolutely no problem. And you can do so at will, because the World Trade Organization is about goods, is about trade in goods and services. And this is neither a good nor a service. This is a government license. So you can just regulate at will, right? There's no international rules about it. So in principle, it can be done. And I'm giving you one example where it has been done. California and Quebec, not an international treaty because one is a state and the other is a province, have reached agreement and their markets have been merged. In the very early days, before there was an EU ETS, the UK had a system of tradable permits and Denmark had a system of tradable permits, and those two markets merged for 3 happy weeks, and then the EU ETS took over. So it can be done, but it has not been done. I'll give you one reason later, after the break. But think of this, right? This is what is going on in China. So would the UK government say, well, let's open our market to Chinese permits and then convince the Chinese market to open up to UK permits? Because who would you talk to? Bits of 10, right? And the other problem is, I won't have time to talk about this. I did just tell you, well, we don't measure CO2, we infer or impute CO2. Very good reason to believe that Chinese emission records are, to a large degree, wrong. That there's a lot of massaging of numbers, to put it politely, going on. You do not really want to have your market flooded with Chinese permits that you have absolutely no way of knowing its quality. Right? So for that reason, we would not open our market to China. We would, of course, be happy to sell permits to China, but because they cannot sell to us, they would not open their market to ours. Right? That's why you need mutual recognition. It's not strictly needed, but it's just, yeah, you can't really avoid it in a practical way. I'm going to break for 10 minutes, and then I'm going to spend time talking about the EU and the UK, probably about the clean development mechanism. I'm not going to get here, so we'll probably skip. Okay, see you guys in 10 minutes. I'm going to talk more about the practice of mostly tradable permits, because that is what is going on in the world. I'm going to start with the European Union. The EU emissions trading system is one of the oldest in the world. It's one of the largest in the world. For a long time it was the largest, but not anymore. Although there are many greenhouse gases, it only covers essentially carbon dioxide, some nitrous oxide is covered, but not any of the other greenhouse gases because that is being too complicated. Similarly, there's a whole lot of CO2, particularly from transport and from domestic use of energy, that is excluded because it's being too complicated to include. The EU ETS works as so-called midstream trade. This is a term that I have not talked about. There are different ways of doing this. Essentially, the question is, who holds the permits to emit? Who do we count? You could do it upstream, which in the case of the EU would be at the point of extracting fossil fuels from the ground that eventually will lead to CO2 emissions, or at the point of importing CO2 into the Union. That would be upstream trade. That idea was quickly abandoned because there's only a few companies that do that in Europe, and therefore you would have immediate issues of market power. So upstream system was very quickly abandoned. You could also do it downstream, that is with the final consumer. So if you want to heat your home, presumably you want to do over winter, then you would need to have a permit to do so for the emissions that that would cause. Economists would say, well, this is actually the ideal system because it's the final consumer who makes these decisions, so we put the decision where it should be. But this was dismissed for essentially reasons of practice, of pragmatism. Because how would this work, right? You would not have a permit for every time you turn on your heating at home, right? That is very peculiar, and definitely I mean, these are electronic permits nowadays, but if you would need to have a permit for every time you turn up the heating at home, that would be a very elaborate thing to do, and it's probably not very practical. So the way that would pan out in reality is that somebody would do this management for you. And there's two candidates for that. One is the banks, right? And every time there is an economic transaction of you buying energy, you would automatically either sell some of the permits that you have or buy some of the permits if your stock is exhausted, right? And the alternative would be that the utilities manage this for you. That every time they sell you a kilowatt of electricity, but they would also sell you the permit that comes with it. The reason that this was not adopted is the system was introduced in 2005, was that at that time a lot of people simply did not have bank accounts or electronic bank accounts. For you guys, it probably would not be a big issue in 2022, right? Because it would just be, you know, have a bank card and it would just be an additional account with your bank, right? And everything would be automated. You would hardly even notice, right? But if you think back to 2005 and you think across Europe, then a large fraction of the population simply did not have bank accounts, and this was particularly true in the former Eastern Europe, right? Countries like Romania and places like that. A lot of people's never been to a bank, right? But also now still in the UK, you see definitely in the older parts of the population that they still are hesitant to use electronic systems, right? So this was simply could not be done at the time for practical reasons, which then leaves the midstream, right? That then becomes the default. You can't do it with the mining companies and the importing companies, can't do it with the final consumer, so you do it somewhere in between, and the somewhere in between are companies that use a lot of energy and are in certain economic sectors. So it's the chemical companies, it's the power generators, the countries that make electricity, the companies that make electricity. They need to hold a permit for every unit of CO2 that they emit, and then they pass on these costs to the final consumer. This is partly done on a sectoral basis. As I said, transport is excluded, but it's also done on a size basis. That has the peculiar implication that you have uneven environmental legislation within economic sectors. So if you take the University of Sussex, for instance, we have a combined heat and power plant, but we are a small campus, so we are not included in the ETS. But if you look at Imperial College, which is a much larger university, they have a much larger combined heat and power plant than Sussex does, and Imperial is part of the, was part of the EU ETS and is part of the UK ETS, right? So we have uneven treatment depending on size. So that is the pragmatic solution that they have. The reason that they sort of lend only for the bigger ones, because there's a whole lot of small emitters, right? And it would simply be a large administrative burden to include them all, definitely at the start of the whole thing. Initially, permits were grandparented, and the plan had always been to gradually transit away from grandparenting to auctioning. But every time they tried to do that, there was resistance, and by now they hope to go for 100% grandparenting by 2030. But given the history, he should not be surprised that that is postponed again, right? These are essentially capital subsidies, right? So a lot of companies need to buy their permits, but some companies, particularly companies that are exposed to international trade, get their permits for free. And those can be very, very sizable subsidies. And there are some companies indeed where their holdings of CO2 permits is the biggest item on their accounts. Talk about this. Permits can be backed. That is, a permit is issued in the year 2022 and can be used any year after 2022. And used means that this year I emitted a ton of CO2, so I'm gonna relinquish one of my permits that I have, right? That is what using a permit means. And you can do that any day after its timestamp. The other way does not work. You cannot use permits that will be issued in the year 2030, no, 2031, sorry, for the year 2022. That does not work. So time travels in one direction, not as it does in reality. But within the commitment periods, you can. So within 2022, you could use a permit in principle of 2030. So within these decades, let's call them that, there's full fungibility over time, but between there is not. And the reason for this is as follows. You could, of course, say, well, for 2022, you need a permit for 2022, period, right? And for 2022, we have 100 million tons of 100 million permits, and that's it. But the economy is variable, as you know. Sometimes you go a little bit faster than expected, sometimes you go a little bit slower than expected, and the weather varies as well, unpredictably from year to year. So sometimes it's colder and you need to heat more, and therefore you need more CO2. So if you have a fixed amount of emissions for a year, well, you may need to fight a war, right? That is also very, very energy intensive. Other things with war as well, but energy intensity is one of minor issues. You may just have a year where emissions are unfortunately high. You had a very cold February, and then it turns cold again in November. And what do? 3 days before Christmas, you run out of permits. And do you really think that the Prime Minister at that time, probably Suella Braverman, will stick her head on telly and say, sorry guys, we're going to, well, you could actually see her do that, right? Sorry guys, we're going to close the country for Christmas, right? No sane politician would do that, right? You need a safety valve here. Therefore, if you aggregate sort of, you'd say, well, the emission permits are not for a year, but for a decade, then a lot of that variability smooths out, and you can actually impose a hard constraint on emissions for a decade much easier than imposing a hard constraint on emissions for each year, right? For reasons of variability and unpredictability. There is a second safety valve, and that is that if your emissions are larger than your number of permits, then you get a fine. And that fine is €1,000 per ton of CO2, which is very high, right? Because the maximum price that we've seen is 90. You can't see it because the projector is in the wrong place. Right? So this is what happened to prices of the EU ETS. As I said, it started on the 1st of March in 2005. And this was the price yesterday. Yeah, the 18th. And you see that there's a lot of variability, right? And prices have gone up and have gone down. What we have seen in the last couple of years is a great strengthening of European policy. And you see prices go up, and of course, things going on in the energy market as well. And then the last couple of weeks and months, prices have come down as our prospect of economic growth has come down. And you also see that there was a price collapse here. I'll talk about that. And price recovered and collapsed again, and so on and so forth. A lot of movements on the market. So this is, I talked about this last week. Taxes don't do this, right? Taxes are flat for a while, and then they jump up or down, but they don't vary from day to day or even within days. This is the average price at each single day, right? So I'm going to talk a little bit about some of the things that happened. I'm first going to talk about what happened here, right? Started with a price, and then price essentially to zero before recovery. And there were all sorts of issues with the EU ETS. The first one that caused that price collapse that you see there had to do with who does the allocation. Not so much grandparenting versus auctioning, but rather who is in charge of this. And initially, essentially to overcome resistance by the members of the European Union to this union project, was that no, we're going to leave it to you, right? Now, as I said in the beginning, the EU ETS covers only about half of emissions. There's targets for 100% of emissions, but really only half has a concrete European policy instrument. And the other half is basically left to soft measures by the member states. So if you're Germany, what do? Well, you say, well, I have half of my emissions that are under control of Brussels, and half of the emissions are under control of Bonn at that time, I think still. Maybe. Well, I think their capital was still in Bonn at that time. What do? Let's see, I'm going to give my companies a few more permits. I'm going to be lenient in the European regulated part of my economy. I'm going to give my companies more permits than they really need, so they have an opportunity to export their permits to the UK, right? And of course, the government in Westminster thought the exact same thing. I'm going to be lenient with my companies. I'm going to give them a little bit more permits than they need, so they can export to Germany, right? And essentially all member states of the EU did the same thing. And as a result, when the market discovered that, the whole thing collapsed, and it took them a year and a half or so to recover. Of course, this was predicted, right? Not only predictable, but also predicted, but it was ignored. And the European Commission now does the allocation. Another thing similar, where they were warned but did not listen, is that the VAT treatment of permits used to be different between countries. So in one country, as you sold permits, you needed to charge VAT on that sale, but in other countries you did not. So essentially a 20% arbitrage opportunity. So what you could do was, now I need to get this right. You bought permits in a country where there was no VAT charged, and then you took those permits to another country where VAT was charged. You collected 20% of VAT on behalf of the taxman, right? That is how VAT is collected. The company does that on behalf of the tax authorities. You do that a couple of rounds, right? And then at the end of the quarter, you have a choice. Either you report your VAT earnings or your VAT collections to the taxman, or you run off to the Caribbean or some other country where there is no extradition treaty, right? And a couple of jokers picked the last option, and they uncovered some of this fraud, but a whole bunch is probably uncovered. Again, sort of teething problems, you could say. People had warned the Commission that this would happen, and lo and behold, it did happen. Austin last week wondered about people stealing things. These are not catalytic converters. As I said, these permits are not permits on paper. They are just registries, electronic registries, free after Lenin, right? As soon as you create a property right, and permit is a property right, there will be theft, right? And the registries were not properly protected. Trade had to stop and stuff because people were hacking into this and stealing permits, essentially changing the records, right? So all sorts of things going on. Perhaps they should have done a little bit better. These last 2 points are the most serious. As I said, CO2 is not measured, but CO2 is imputed from energy use. And essentially what you need to have is parts of the civil service collecting information about energy use and double checking that that information is indeed correct. You need to have a monitoring system somewhere in the civil service. Now in Romania that was done by a single civil servant until she got pregnant and went on maternity leave, and Romania did not monitor its emissions for a year. It's the free-for-all in Romania, right? Romania, as a result, was kicked out of the United Nations emissions trading system, but stayed in the EU, right? The UN emissions trading system doesn't function, right? It just doesn't exist. There's no trade there. Similar problems, not with pregnancy, in a few other countries. I believe Estonia and Slovenia had similar issues with monitoring. And this is a serious issue, right? These are valuable property, but at the same time they're intangible property. So it's not that somebody stole your bike or somebody stole your car and you immediately notice it is missing. Oh, this is something intangible, and only once a year we sort of like see where all the sums add up. Typically in April, sometimes in March, depending on the country. So this is a serious issue, and very much related to the final point here. And that is who does the monitoring and who does the enforcement. As I said, the initial allocation was done by member states until that went wrong and the European Commission took over. It sort of makes sense. But the monitoring and enforcement is still done by the member states. And worse, emission permits are so-called seller beware. So there's two systems of consumer liability. Most things are traded under a system of buyer beware. So if you go to the supermarket and you buy a bunch of oranges, you pay for the oranges, you walk out of the supermarket and you discover that they're all rotten, that is your problem, right? You can't go back. You should inspect your fruit before you pay for it, right? As most people do. So that is buyer beware. For a few goods, we have a seller beware system. So if you buy a second-hand car, you pay for it. If within 2 weeks you take it to another garage to have checked, and it turns out that the seller has lied to you about the condition of the car, you can take it back, right? So that is seller beware. Or if you have a house built, not something that you're thinking about at the moment, if within 7 years of the house being given to you, transferred to you, you discover that there's something structurally wrong with the building, you can give it back to the developer and get all your money back, right? And this is, of course, Akerlof's asymmetric information, right? That is why we have these regulations in place. That sometimes as a buyer, you are simply have less information than the seller, and you need to be protected against that, right? Emission permits, contrary to what I just said, are, no, I did say that wrong, are seller beware. That is to say, if a German company buys an emission permit from an Italian company, and it turns out that that Italian company did not cut its emissions, but just sold its permits, it was a fraudulent sale. If the German company discovers this, it needs to call up the German regulator and say, I accidentally bought a fraudulent mistake. I made a mistake, I bought a fraudulent permit, right? Then the German regulator said, thank you for notifying us, you're off the hook. And then the German regulator needs to call up the Italian regulator and say, one of your companies did something wrong. And then, of course, the Italian regulator will say, thank you very much, hang up the phone and go back to sleep. Right? So enforcement is as strong as the enforcement in the weakest member state. Now, I pick on Italy, not because of Marcos, but we know that the Italian legal system is not the strongest in the world. We know that for a very long time they had a convicted fraudster as the prime minister, and now the sucker is back in power, right? Not quite as powerful as he used to be, but he's back on the front benches. It's not just Italy, right? We also know that Spain did not think anything about falsifying its milk records, and it's looking at you, Miguel, assuming that you're fine. Very good. Portugal did not do these things. Don't make assumptions about somebody's nationality based on their name, right? But Spain did not think anything about falsifying its olive oil production numbers in order to get more subsidies from the EU. Greece did not think anything about falsifying its GDP in order to get into the euro, right? It doesn't stop there, right? We know that organized crime is part of the government in Bulgaria, and we know that the Russian mafia is in the government in Cyprus, right? These are the people that enforce the EU ETS. And for that reason, back in 2008 or 9, there was a discussion between the Americans and the Europeans about coupling the EU ETS to the RETI system that I talked about before in the northeast of the US. When the Americans looked at European enforcement, they walked away. They said, we're not going to trade with you Europeans because enforcement is so very weak. Absolutely. Um, well, the European Commission is very small. It's a very small civil service, right? So what they can do is ask member states to collect this information, send that to them, and then based on the spreadsheets that result, make an initial allocation. But they cannot monitor emissions, and they cannot monitor emissions because they simply do not have the human power for it. No. Frontline services, such as collecting data, and frontline services such as sending bailiffs and sending the police after, are all in the member states. The European Commission simply cannot do that. It does not have the human resources to do so, and it does not have the power to do so. This is something that is very carefully guided by the member states. You're from Poland? Yeah? Do you really think that your government would give Brussels the key to its police force? Right? This is fraud. This is fraud, right? Prosecution of fraud is done by the national authorities. And yes, there is a European Commissioner that looks at these things, and he or she, I don't know, has a staff of a few hundred people that sort of like give guidelines and cajole people, but the actual prosecution is done by the Polish authorities. Right? The European Commission is simply not in a position to do so, and no member state will ever transfer this power to them. Right? Okay, so that was the EU, and all this used to apply to the UK. It doesn't anymore, or so you would think. The UK now has its own ETS, which officially started on the 1st of January 2021, so it's almost 2 years old now. As so many things with Brexit, this was absolutely not necessary. Iceland, Liechtenstein, and Norway are all in the EU ETS, but are not in the EU, right? So the UK could just have stayed in the EU ETS, but didn't. This is a typo. The UK did it about whether or not to stay in the EU ETS, right? That was since 2016, there was a discussion, shall we stay or shall we not? And in 2018, the European Commission was just so fed up with this, like, make up your mind, guys. Will you stay in the EU ETS, yes or no? That in 2018, from 2018 onwards, they actually suspended the free allocation of permits. So the grandparenting of permits to UK companies ended in 2018, even though the UK was still in the EU ETS for another 3 years. As I said, this was a large capital subsidy, and this is one of the reasons that British Steel went bankrupt, because essentially they lost their grandparented permits. They were still part of the EU ETS, so they still needed to have permits, right? So instead of getting them for free, they now had to buy them on the market. So that was one thing. Then for a long while, the government was also not sure what to do next. When it became clear that the UK would no longer be part of the EU ETS, they could not make up their mind whether they would have a UK ETS or a carbon tax. And that final decision was made only November 2020 or so. And then they had 2 months to set up a UK ETS. That did not work, right? So the first trade was actually done on the 19th of May 2021, which is still actually remarkably quick. Further to all this, the UK ETS is, no pun intended, a carbon copy of the EU ETS. Essentially, all the rules and regulations are the same. So that's, we replaced essentially the label. There's one difference on paper. The UK introduced the so-called cost containment mechanism. This is a set of complicated rules. If the price goes up by too much, then we're going to intervene in the market. That has happened twice. The conditions were met to trigger the cost containment mechanism, and twice nothing happened. So essentially, the UK ETS works exactly the same as the EU ETS.
It's that awful price increases process that by the government.
Essentially, the rule is that if this happens, if the average price is greater than the price of previous 2 years for 3 months in a row, this has happened twice, then a committee will meet, and the committee will decide whether or not to intervene. And the committee has twice decided not to intervene, right? But that did not fit on the slide. This summarizes what happened. So the EU ETS works exactly the same as the UK ETS. The price development you see here, the red are the auctions, the dots, various colors are the futures, and you see the price is variable, goes up and down, and in the most recent weeks it has come down. This is the price until last week, last Friday. So this is what happened. The price in the UK has been higher than the price in the EU. And the reason for that is simple. Throughout the 17 years that the UK was part of the EU ETS, the UK has always been an importer of permits. It has always been the case that it was cheaper for UK companies to buy permits from particularly Poland than to reduce emissions in the UK. And if you close off a source of cheap imports, then the price goes up, and that is exactly what happened. And you see the prices here. Of course, there's an exchange rate issue as well. The total cost of this was 1.2 billion last year. This is just money lost, right? For no reason whatsoever. So I have 15 minutes left, so I'm going to skip border adjustments, and I'm not going to do technological change. So technological change will also not be on the exam, right? Instead, I'm going to talk about the clean development mechanism, because it is different and it has important lessons as well. So far, I've been talking about emission permits. And emission permits work as follows. A country says, I'm not going to emit more than 100 million tons of CO2, and therefore I'm going to create 100 million permits to emit 1 ton of CO2, and that's it. There's a lot of countries that don't have caps, that don't have emission targets, but do have opportunities to reduce their emissions. So how would you include these countries into your system of tradable, not permits, but credits? The clean development mechanism, used to be called joint implementation, allows rich countries to invest in emission reduction in poor countries. Poor countries do not have emission reduction targets, so instead of trading in permits, we trade in credits. And a credit is defined as follows and created as follows. Essentially, you create a project, and what you say is that because of this project, emissions have fallen. So you have your project, and you have the counterfactual, the world without your project, and you say, well, emissions have fallen, will fall. And then the difference between emissions with and without the project are your credits that you can then sell to whoever wants to buy. And this is complicated because we're not having a reality, total energy use from which we derive emissions, and that's it. No, we now have the difference between two counterfactuals with and without the project. So what you need is a lot of documentation that, yes, I can prove that I will reduce emissions by so and so much. And you need a bureaucracy to check your submission, right? To check your homework. This is a hefty bureaucracy. You need permission from 17 different committees to get your project approved. You may have noticed that I used the number 17 a lot, and it's a random large number. It actually comes from this because it's really 17 in this case. In most other cases, when I say 17, I mean just a ridiculously large number. But in this case, it is really 17 committees that need to look over your application. And because of that, two things happen. A, small projects are simply not worth the bureaucratic overhead, right? Because there's a large fixed cost to this. And second, poorer countries that don't have the capacity to write these project applications are excluded from the market. Or poorer countries that don't have where the economic means to buy in the consultants from foreign countries to do this for them, right? So the CDM, even though it says development in its title, is very much geared towards middle income countries, not the lower income countries. They are typically excluded, and it's very heavily biased towards larger projects. And there's typically also a price wedge between there's always a price wedge between the price of a credit and the price of a permit, around 1 to 2 euros per ton of CO2. Now, there's all sorts of things that can go wrong, right? Because this is all counterfactual. So you can imagine that this is hard to do. One famous example here was something that went on in China for a while. And it was about HFC 23. Now, you've never heard of HFC 23. This is a hydrofluorocarbon. It's essentially a chemical that is used as a refrigerant and as a solvent. It has industrial applications, but it's a bulk chemical. Everybody can make these things at a pretty low price. So the industrial value of a ton of HFC 23 is not that high. It's cheap to make, but everybody makes it, so it's cheap to sell. It's cheap to buy as well, but not very profitable. HFC 23 is also a greenhouse gas, and it's a very powerful greenhouse gas. 1 ton of HFC 23 causes as much warming as 23,600 tons of CO2. So the climate value of HFC 23 is very high. So what did some jokers in China do? They built a factory to make HFC 23, and they said, we're going to turn on this factory and dump all the HFC 23 into the atmosphere. Plan A. Plan B, we're going to close down this factory. Right? It's a clearly defined project, and you reduce your emissions by a lot, right? And you can sell those permits for a lot of money. So that is what they did. They sold the permits, made a lot of money, built a factory, took down all the machinery from the factory, put it up in a different place, and repeated it, right? They've taken HFC 23 out of the system, but there's still things like this going on. I've been in this climate game for a while now. And as I said, the Clean Development Mechanism used to be called Activities Implemented Jointly or Joint Implementation for a while. And back when I was about your age, I sat there and somebody was standing on this side of the room and was talking about these project-based credits to essentially reduce emissions elsewhere. And we were sitting in class, a relatively small group of students, and one of my fellow students, an old friend, way smarter than I am, not academically, but obviously smarter. So we sat in the room and I was nodding along and making notes for to teach this stuff decades later. Bernd was his name. Took a different lesson from us. He had just inherited some money from his grandmother. And what he did with that money was that he went to Indonesia, that's where his grandmother's family was from. This was in the Netherlands, right, former colony, and bought up a motorcycle factory. And what he did with the motorcycle factory was that he closed it down and fired everybody, sold the buildings, sold the machinery, and he had obviously reduced emissions because that factory was no longer operational, right? So emissions had fallen. So he sold the permits, the credits that he made, and he had enough money to buy 2 factories. And he continued that process until, for a couple of years, till he had so much money that he just decided to go float in the Caribbean for the rest of his life, right? He hasn't been seen since. But presumably he's leading a great life. Now, he did not reduce emissions, right? He closed down that motorcycle factory, but he did not change the demand for motorcycles. So somebody else just picked up the slack and sold motorcycles instead. So yes, within the confines of the project, emissions fell, but overall emissions stayed the same. He did make a good few people unhappy, right, because they lost their jobs or had to relocate, but he did not cut emissions. Right? So yes, clean development mechanism exists, but there's all sorts of things that can go wrong with it. It's heavily biased, does not necessarily reduce emissions. Unfortunately, there's also papers that show that it actually does not actually stimulate development. It does not actually increase the economic growth of countries.